Good morning, everybody. It's time for our next trigonometry lesson. Let's start by reminding ourselves that the trig problems that we were doing in the last section all had to do with triangles. And so all the angles inside the triangle were acute angles because we had a right triangle, so we had 90 degrees in one corner, and then we had smaller angles in the other corners. So maybe, for example, we had a 41 degrees over here, and then we had a 49 degrees over here, something like that. So all of the angles other than the 90-degree angle were acute. So today we're going to talk about what about angles that are bigger than 90 degrees? How do we do trigonometry with angles like that? Because then we wouldn't have a hypotenuse, so we wouldn't be able to use SOHCAHTOA to define the angles or to define the trig ratios. So today we're going to talk about angles in what we call standard position. So standard position for an angle is where you take any angle and you put its vertex on the origin. So it sits right there at the origin. And then we call the base of the angle, where it starts, the initial side. And we always put the initial side from the origin going over to the right on the x-axis. So this is called the initial side of the angle. And then wherever the angle stops, maybe over here, so the angle I'm talking about goes from here to here, that would be called the terminal side. So where it starts, that's the initial side, and where it stops, that's the terminal side. And the angle is the space in between those two. And so it doesn't matter how far out you draw the little arrows, that's the same size angle as the one that I originally drew, because the space between the two sides is what we're measuring. That's the angle. And a lot of times we use Greek letters to define angles. So you'll see me writing this Greek letter sometimes, which is theta. Another name that you see sometimes is alpha. So I'll write that down. This is theta. That's a common one that's used for an angle. And this one was just alpha. And they're just letters from the Greek alphabet. That way we know that the thing that we're talking about is an angle as opposed to a side or some other point or something like that. So the Greek letters oftentimes are used for angles. So this is what we call an angle in standard position. And you can draw any angle of any size, even if it's more than 360 degrees. It's kind of funny, but if you draw your axes and you wanted to draw, for an example, an angle theta that was 410 degrees, you would start, like I said, on the initial side, the x-axis, and you would rotate around, so 90, 180, 270, 360, and then I need to go 50 degrees more, so that would be maybe about right there. And so the terminal side of a 410 degree angle would be right there, which is funny because a 50-degree angle would look exactly the same as that. And so I'm going to change colors here. Let's change to blue. So a 50-degree angle, if I had alpha equals 50 degrees, it would have its terminal or its initial side in the exact same place as the 410-degree angle, and it would go 50 degrees. Oh, and by the way, we always measure counterclockwise. Positive angles are counterclockwise, negative angles are clockwise. So this is a 50-degree angle, but it lands in exactly the same spot as the 410-degree angle that I drew with the black pen. So these two angles right here, positive 410 degrees and positive 50 degrees, are what we call coterminal because they end in the same spot. Now, if you wanted to, you could get really creative and you could do another angle that was coterminal with that by starting in the same exact spot right here on the initial side, always on the positive side of the x-axis, and then rotating in the reverse direction all the way around and ending up again in that same spot. Now what would that be? Well, if you think about it, that's 360 minus the 50 degrees that we already have marked off there in blue. So that would be, I'll give it another Greek letter, that one's beta. I'll say beta is negative 310 degrees, also coterminal with the other two because it ends in exactly the same spot. So if I didn't have those swirlies drawn there, the blue arrow and then the purple arrow and the black arrow, you wouldn't be able to tell the difference between those angles because they look exactly the same, right? They start on the positive side of the x-axis and they end right here. And so what I've drawn in yellow there, that angle, you could call it 50 degrees, you could call it 410 degrees, you could call it negative 310 degrees. All of those are different ways of measuring out that angle. But if you were wanting to measure the distance between, the shortest distance between the two yellow sides of the angle, you would want to go with the 50 degrees. 410 gets you to the same ending spot, but you went all the way around, and then obviously negative 310, you went in the reverse direction and ended up in the same spot. So that's what we call coterminal angles. All right, so we're going to get used to drawing all of our angles in this way in standard position. And then we also have to get used to another concept. And the other concept that we have to get used to is the idea that there's more than one way to measure an angle. Just like there's more than one way to measure how tall someone is. You can measure how tall someone is in centimeters or in inches. You can measure how heavy someone is in kilograms or in pounds. We're going to learn to measure our angles in another unit, and that unit is called radians. And I found a really cool video of a math teacher describing radians, and you can watch that after this, but I'm going to give you my boring explanation. So 1 radian is a lot bigger than 1 degree. 1 radian looks about like this. Okay, that's about the size of an angle that has a measure of 1 radian. And so the conversion factor that we use is that 180 degrees, which you guys know is a half of a circle, is equal to 3.14 radians. It's a weird conversion factor, but I bet you can guess where it came from. It comes from the number pi, which occurs in nature as the ratio of the circumference to the diameter of a circle. So it's a very famous number. And so 180 degrees equals pi radians. Now, the cool thing about radians is it's the default unit in trigonometry and in calculus, actually. So if you're measuring an angle in radians, you don't even have to write the word radians. You can just put pi, or you can put 7, whatever you want to put. But the conversion factor is 180 degrees equals pi radians equals 180 degrees. So we use that to convert angles into radians, and oftentimes we leave it in terms of pi. So 1 degree, I can't even draw 1 degree on here, right? 1 degree is this teeny tiny little angle, okay, like 1 degree. It's really, really small. But 1 radian, you can actually see what it looks like. It's a pretty decent sized angle. But let's say we wanted to take a measurement of an angle. Let's say we wanted to take 135 degrees and we wanted to convert it into radians. So 135 degrees, to convert it into radians, you use the conversion factor of pi being equivalent to 180 degrees. And again, I don't have to write the radians because it's implied. That's the default unit for angles. So pi over 180 is equal to 1. This is just the number 1 because those two are exactly the same amount. It's like $1.04, same amount of money. Pi radians, 180 degrees, same amount of degrees. So when I multiply by this conversion factor, I'm really just multiplying by the number 1. And so I get 135 pi over 180, which looks really awful, but 135 and 180 actually have a common factor of 45 degrees. So this reduces to 3 pi over 4, or 3/4 pi. Sometimes you'll hear people say it. Now, let's see what that looks like. 135 degrees is right here, okay? And it is 135 degrees. It ends up in the second quadrant. And if you were going to describe that angle in radians, you would just write 3 pi over 4. So you could name it either way, or you can measure it either way, I should say, 135 degrees or 3 pi over 4. Let's do another angle. That's very common. Let's do 60 degrees. A 60-degree angle, well, that's 45 degrees. Sorry, I need to draw it better. Let's do a 60-degree angle. 60-degree angle would be somewhere like about right there. Okay, so you guys, 60 degrees, that's a familiar angle to you. 60 degrees if we wanted to convert it to radians, we would multiply by pi over 180. That would give us 60 pi over 180, but 60 and 180 reduce, and we get pi over 3. So you're going to find out really quickly there's some very common angles, and you're going to see the same fractions of pi over and over again. Let me start off with the smallest one. 30 degrees, get used to it everybody. 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. And 90 degrees is pi over 2. So those are the most common ones, and every other angle that we deal with commonly is a multiple of one of these. And if you think about it, it makes sense if you think about 180 degrees is a half a circle, right? Here's 180 degrees all the way over here. So it would start here on the positive side and it would end here on the negative side of the x-axis. So 30 degrees, if you broke 180 up into 30-degree chunks, it would be 1, 2, 3, 4, 5, 6. So each one of these would be pi over 6, pi over 6, pi over 6, pi over 6. And then if you add up all 6 of those, you get 6 pi over 6, which takes you all the way to 180 degrees. And you could do the same thing with pi over 4 or pi over 2, 90 degrees. Think about it. If this is 180 degrees, then 90 degrees is half of that. So you've got pi, and here you've got pi over 2. So they're all just fractions. And there's a nice picture in your textbook that you can take a look at on page 777, which shows all of the common angles given in both degrees and in radians. So watch the video, because I think the teacher that describes the video does it really well. And you'll see what I'm talking about. And you're just going to have to get used to this different unit for measuring angles. So your homework assignment is going to have you converting from degrees to radians or from radians to degrees. Ooh, let's do one of those. What if we had, for example, 5 pi over 3? Okay, it's a multiple of one of our common angles, pi over 3. See the pi over 3 right there? So it's 5 of them. But you can convert it by taking 5 pi over 3 and multiplying it by 180 degrees over pi. So take that conversion factor, turn it upside down. It's still equal to 1. And you can easily convert because it makes the pi's cancel out. 180 divided by 3, that reduces to 60. And then 5 times 60 is 300. So we've just converted it from what was originally radians, and now we've converted it into degrees. So in your homework, you're going to have to do some converting. You're going to convert from degrees to radians or radians to degrees. You're going to draw a whole bunch of angles. And then you're going to also talk about one other concept. After you draw them and convert them, the final concept we need to talk about today is called a reference angle. When you have an angle that's larger than 90 degrees, so for example, let's draw, I don't know, 210 degrees, okay? 210 degrees. I know that that's more than half of a circle because it's bigger than 180, and it's 30 degrees beyond half of a circle. So I drew it in the third quadrant there, 210 degrees. And again, positive means go counterclockwise. What we have for every angle that we're going to need to do our trigonometry problems that are coming up in the next section is we need to know for every angle larger than 90 what its reference angle is. And a reference angle is described as the shortest distance between the angle and the x-axis. And so the reference angle in the 210 degree example that I did right here is this little piece of the angle right here, the shortest distance from the angle to the x-axis. And it doesn't matter if you have to go backwards or forwards. So for a 210 degree angle, the reference angle would be 30 degrees. Reference angles are going to become important because we're going to learn that for large angles, their sine, cosine, and tangent values are the same as the sine, cosine, and tangent of their reference angle. So the reference angle is always less than 90, and it's always the shortest distance from any angle back to the x-axis. So let me give you another example. I'll do this one in radians. If it's given in radians, you should answer in radians. So let's say, let me think of a good one here. Let's do 2 pi over 3. 2 pi over 3 is right here, okay? 2 pi over 3 puts you right there. And again, I've done radians long enough. I'm comfortable with them. I know for you it's a lot to take in. But that's 2 pi over 3. So its reference angle is this little piece right here, going from the terminal side of the angle back to the x-axis. How far is it? The reference angle is important. And so if this is 2 pi over 3, to get all the way to the half circle mark, which is pi, I would need another pi over 3. So the reference angle is going to be pi over 3. I sometimes just call it the RA, reference angle. The reference angle is going to be